Okay, this is Durwood King with MNT 110 class, and we haven't done any Zoom sessions, but we're doing one today for a student that is not able to be here. And so Brandon, if you are watching, either recording or live, I don't think you're on live yet, but we are recording so you can catch everything. And this will be recorded and put in YouTube as well. And this is a mechanical maintenance procedures class. And for whoever may be watching, and this is October the 22nd, 2020. And we've not been doing Zoom in this class. There's been no need to do it until today because someone that can't be here that needs to be involved in the lesson, in the session. Okay, so let me send a message to one student here. You find one that's tighter. I know that. How far is it? Brandon, this is Durwood. We got the Zoom session going. If you can get in, plus I'm recording it. So whatever you can do, if you can get involved, that's good. So you can talk back and forth. Okay, thank you. Call if you have trouble getting on. It's in the MNT 110 Moodle webpage where the link is. Thank you. Okay, so I'm sending him a text. I just give him a voicemail, so we'll go ahead and start. And we're recording. We are recording. So what I want to do is roll this thing around, and I want to include whatever we're doing through this session. Let's figure out. I know what we're up to right here. Now, where did we leave off? Keep that there. I'm going to leave right. So we do need to finish that. Need to finish that. Put it back together. We're going to do back last check with a dial indicator, and axial run out, and radial run out with a dial indicator. That's a couple things that's in the book that we haven't done. But we I don't think we checked your 2% on this. I don't think we did. Do you remember me checking out over here? I don't. I know we did yours. Right. So let's take this here off. Yeah. And let's include. All right. Brandon, you were involved in checking the 2% chain sag on your lab. We hadn't done it on this one right here. I'm just going to let you kind of see what we're doing there. This part will be a repeat for you, but you hang in there, and you'll be getting new stuff on the gearbox that you haven't seen. So, anyway. So that's it. Okay. Now, today's the difference in time. Your stamp, what is your stamp? Your center seal? 12 3/4. 12 3/4. 12 3/4 times 2% is what? Because that's what the book calls for. That's what it calls for on Saturday. Approximately 2% of the play on one side of the center. So y'all figured that to be 4 times. That's so. You lay that up there, let's push down and see what we got. Stand up. So see, this is this play. It won't play like that. Won't go back in like that. And that way, for whoever may be watching this, I don't know who's. We're going to put just a moderate amount of pressure there, and you have that 1/4 inch right there. And can I go any further? Yes, I can. I can go extreme with it, but again, it's a general rule there, and that would be your sag. And Pat, from your experience, would you think that's pretty good, or you think that's maybe a little too much?
It is a little too much.
It feels a little too much. It does. So let's make an executive decision here. Let's lighten up a little bit, because I might even say lighten up a chance more. Yeah, honestly, maybe even a little lighter. Oh.
I think maybe a little tight.
Just split that hair like a frog hair. A frog hair, Brandon. A frog hair.
Yeah, that's about where
I would agree with that too. So honestly, these books, listen, that 1/4 inch thing we just did there, that's subject to how much I press. And they're not specific on how much you press. They just say 2%. Well, that's pretty based on how much you push. It's not a really.
that's not going to put load on the bearing.
Exactly. So you do have to think about the amount of load on the bearings on both of them, the shaft, or you're going to create more problems there. So that's good. And let's look at the direction of the master link. And if it goes clockwise, that's correct on that clip. The random end would be facing. Is that your direction? Is it clockwise? I don't remember for sure. I know that one. Okay. So we'll put all these. Let's put them in a little container thing and all that stuff. So there's nothing. We don't have any projectile, Man. Patrick's got the Mac down here on this. Yeah.
Yes, they keep locked out.
Hey, Derek.
I can set it on scan. On scan mode. set the temperature on it. If it's over, it's temperature over. I got to set on 99. I got to set on 99.4. So if anything is over 99.4, it'll be. If I'm not at
Brandon, you hold on a minute. We're not done here. Let me get a grab.
So somebody could walk in. If they're over 99.4, they'll start beating.
Everybody got that door. You think you'll do it over there?
Pick up. On way.
No. Yesterday we were in here and air conditioning kicked on. And it started making this weird noise. Then everyone the lights started flipping. Oh no. They lost the lead and had their own power. Something burned up over there. That whole area there. We walked in there and it smelled. How much is that?
How much? Definitely take more for the technology, the gas, the price will come down. You got a lease connection for your house, something in your house, you take all the stuff off and walk along, look at it. Well, out there, it's about long. Sit around almost 80 costs to look at
We can't see through anything.
No, they won't show you. Nope, they won't even go through plastic. It's just surface. You look. Put it in. They're gonna roll call. What's it there with? How to temperature on you is right on your ear. 97.5 degrees. Wow. I got to set it 99.4. So anything over 99.4 it starts beating.
So then we got to go to quarantine.
Pat's been going around Walmart. He was in there shopping. He was checking people out.
And it'll do video like that.
He was walking around Walmart and he was in there checking, make sure everybody was good.
Sent myself up a lawsuit. No,
They could actually do that. I mean, if they, seriously.
Yeah. As people, if you have a group of people walking through that door, you can sit here with that gun. If somebody's temperature is up, it'll be.
Wow.
Who it is.
You call the health department.
Click that button and take the picture.
You call the health department with a big van, lock them up, lock them up. Take them. Go lock them up in the basement somewhere for 2 weeks, right?
Some places we're doing that.
Really?
I think it's
That's in Chinese.
Philippines.
Really?
I think it's in the Philippines. If they found out you had it and they took your temperature, if you resisted them taking you, they were ordered to. Said like I said, on the news, they were ordered to shoot you dead.
Joe.
North Korea, if you got it, they lock you in your house and nail up the door.
Nail them up.
That's one way to stop it.
I mean, that's critical. That's what they're going through.
Juice.
Okay, so let's make sure everything is nailed down good solid. Okay, so we've got our 2% stag here. And we're going to get out of the way when this thing starts up, and we're going to get our RPM tachometer out ready.
Yeah, tape.
Yeah, let's put some tape on it. Let's unplug it while we do that. Technically, let's put the lockout shell on it. So notice it can't be plugged in while we'll probably put tape on there. So here, the tachometer comes with tape, reflective tape. And so we're going to cut this little piece off of there. It's got little sparkles on it. Cut your little piece up, and then you put it on your subject there. I got my track supply special. Needle nose, whatever you want, man. I got all these screwdrivers on here. Scissors. I even got scissors on here. Look. There's a spring back there, but it's actually
Piece of metal in there.
it's still pretty good. It's not. I paid what, about 40 bucks for that. The size of that. Where that. I like the little tool, man. Got all the tools are locking on it. Get you peel that off right there. Let's wipe it off when we put it in. Stick it on. Let's get a little paper towel and wipe it off. Just get all the grease off of there so hopefully it won't come off. Yeah, just get you a good dry spot. Put it somewhere not over a boat so it can just stay on there. A flat area somewhere. Yeah, but I like that right there. It's very, see, it locks in so it don't, you pull it down. Things like that. It's got all these other tools, screwdrivers and the file, man. It's got all kinds of stuff. It's even got a Phillips. It's got a flat and it's got a Phillips. It's got a flat Phillips. Look at that. That's weird, isn't it? But it's technically it's a Phillips. Okay, so here we go. We got this. We're going to need this here out of the way to get an accurate reading once we get it started. Let's get it started and make sure that everything is secure, and then if you try shooting it through this, then it may do fine. Everybody got safety glasses. Put our tape back over here. That is special tape. Tape in the end of y'all thing here. Okay, and when you plug it in, don't be in the line of fire. If that link comes loose, you're going to step out here and do it, please. If something's going to happen, it's probably going to happen when we first start that, if anything is. Right, stand out here somewhere when you cut it on. Okay. Okay, so just in review there, that tachometer will do it with a photo eye, with a light that bounce off of that tape, or it'll do it direct contact. Whatever mode you're gonna put it in, you got to tell it here for photo electric, or direct contact. I mean that slider, direct contact for the wheel. If your shaft is pre-drilled, it's not pre-drilled, so we got to go photo eye, which is actually better. Photo electric. Plus, if you have a requirement to check surface speed versus RPM, you can put a roller wheel on this thing, pop it on, and go feet per minute or meters per minute on actual surface speed. Some things might require that when you're doing these measurements, depending on where you're at. Like certain conveyor belts might say it's supposed to be going at X amount of feet per minute travel, maybe at the lumber yard or whatever. over there at Turlington, they got a lot of stuff over there that they're using. Okay, so photoelectric, and you want to go at a right angle to that, not like that. You want to go straight on with it and hold that button in, and let's see. First of all, check the motor. And you may not be getting a good signal through this. Press it in. And I thought we'd put batteries in that the other day. All right, let's get the other one out then. I know we did.
Bearings, 79.5.
So, will that pick up the whole screen, the auto section?
Yeah. But right now I got to set because that was a square box right here. Expand that.
There it went. I had to roll the batteries around a little bit. I knew we put new batteries in this thing.
Now to pick up in that whole box.
I got a screening mode. Got a screening mode that picks up everything. Everything.
There you go. It's working now. And just roll the batteries a little bit. I'm gonna get our little camera here around, kind of move it around some. You're sitting on photo. 1,789 RPM. Now the motor says 1725, but that just shows you that in reality it may not do exactly, it may do more than what that nameplate says, and it is in this case. 1785. It's going to shoot it over here. You're going to get a lower reading over here. You see that photoelectric light shining on there coming from that tachometer? And it's blinking back and forth like that. It's giving them a reading there, 759, about 760 RPM there. So you're going to the original arc box. Yeah. Now using direct contact. $750. So it's pretty accurate. It's very, very accurate. So whichever way you have, I kind of like the photoelectric. The photoelectric tachometer part because it's less risky on something going wrong. You don't have to touch it. You see that light bouncing off of there? Just getting a reading. So from 1788 to 750, is that what it was? And we've already been through the book how to do the calculations on the ratios, all that stuff in the chapter on chapter 12. So you cut that off. Well, actually cut it back on. Just give it. I want to give it a little video. Patrick's got a real Cadillac. He's got a real high-end infrared camera. It's even a step up from what we got. We got a FLIR brand, but he's got one from Bay Valley Foods. And so tell us what are you looking at? The bearing? So you want to see what he's got here? Right now he's looking at the bearing temperature. And it's kind of cold, Patrick. Tell us about this thing.
That bearing is not hot. It looks like it's hot. I think it's going to be 40 degrees. But the house is almost 59. The bearing
got the focus set now. So where on the screen are you looking at right now for that bearing? Yeah. Now, I got the angle changed there. How about now? That looks pretty good. Got to refocus here. Pretty. Yeah. Let me get the camera still and just so I don't have it. Hold on. Now, let me move it here. Actually, let me cut the there's a way to cut. Well, there's a way to cut that light off. That was it. Yeah, that might have been putting the glare on it right there. Yeah, that's what it was. It was around the light putting the glare on it. So let's get that focused there.
Tap it again.
Did it cut off? Yeah. It's just a reflection off the lights, the bay lights. Now that light, that's a little better. That's probably about as good as you're gonna get at an angle, so it doesn't reflect so bad. So you're getting the.
That's the hottest area right now.
That's the hottest area right there in the bearing. I back out some. Move.
You see the whole bearing housing starting to heat up now where the heat is transferring.
Right, it is. It is transferring. Yeah. But where the crosshair is, right there in the middle. In the middle is what you're reading. What up here? Over there. Okay. So that the temperature, you can't see the crosshairs on the screen, but it's right dead center. It's 83 degrees. So with that camera, even though it looks like it's cherry red, like it's had a torch on it, it really hasn't. That's the actual temperature right there, up in the upper left. So if I get that focus there. Anyhow, so this is a handy tool right here to know whatever your baseline is on temperature. You know, you would just have to stay within that, and you can set alarms on this cancer pack.
Yes, sir. Yes, sir.
So if you get an alarm, what does it do? Does it beep?
It beeps.
It beeps. Okay. So this is a real fancy setup. It's a step up from what we have. We got a pretty nice one, but that's a step up. Cooling down, it's going down to 80 something degrees, so you can see that.
You see how the heat is transferred to the housing.
Yeah, it is. Yeah, pretty neat, ain't it? It's real neat. Yeah. Yeah. But if you're talking, you know, you're talking of a system that might be a $500,000 machine. You know, you go out to hog slap, that new hog slap place where they got laser cutters and punching machines and stuff for making hog feeders, man. Exactly. That's what I'm getting at.
So I can be standing over there and you look at through here, and they'll get a hot spot on it.
Yeah.
You can put it on, well, actually, put it on a tripod. Right
Okay. I like that. Tripod be nice.
it's kind of
Get rid of all the shake, you know.
Probably check out wastewater pumps in the pond. So they have to go out there and vote and check the temperature of whatever I stand up here.
So how far out would it do that?
Those are about 50 yards out.
50 yards.
But as long as it's in the view, it'll give you the temperature. It's pretty accurate, but it's kind of hard to hold it steady.
That's good. All right. So that you did good. You did good on that setup right there. And what we're going to do now is move over. We've got
Gotta put that bearing on.
We're going to finish putting that bearing on that we didn't get pressed all the way on the other day. So that's where we're heading over here, Brandon. So I'm moving the camera through the shop here. And, so you'll bring that on over here. We're going to do that little real careful press. So now, if we take these, you can get these with all those on, and they ain't but about, probably around $2. They're real lightweight and they're real small. They don't take that much space. Got a clip on, so all those on where I got that. And let's show on the camera what we're doing here. So let's take this and hold that up, and let's bring it up here. Let's explain what's going on. So the other day, angle it so we can see that gap in there. One more time. Now the other day, if you look, when these guys press this bearing on, press the shaft through the bearing, there's a gap in there. If you see the gap in there where I'm pointing with the pencil, it didn't go quite all the way on because when it was pressed, it pressed flush. Let's go back this way. It's flush right now. And so it stopped that it's got to go just a pinch more to get rid of that gap in there so that the bearing's fully on and it's going to have the clearance it needs in the gearbox. So for that, we're going to have to put this into press over here. And with our parallel bars, we've got to spread the parallel bars out so that we're going to support the inner race of the bearing and not have interference with the shaft to press it all the way through. So what he's doing here is he's putting, and I can shoot this from the bottom end with this. Light on. Let's shoot this.
When we get the mirror out, we got a camera.
Exactly. Hey, in that thought, yeah. So exactly. Let's do that. So right now, we want to adjust it so that we've got that we support the. We get the camera set right. You want to support the inner race on, but not have any interference on the shaft. So go out a little bit further, little pinch hole, and then how about the other? Just a smidgen. That's good. So right there's where we want to maintain it. When you get the ram, a little bit of tension on that ram, let's double check this with the camera, okay? This is actually very good to have this camera like this. I like this one.
All the focusing is good, ain't it?
Well, actually, it's manual on this one.
Is it?
Yeah, the autofocus one never came in, and they ended up saying they could not get it.
It's doing some kind of focus.
It's doing something.
Yes,
It may be when I move.
Yes,
I don't
sir.
know.
Because it will focus. When you put it under there, it's real close and it's focusing itself. Back it up a little bit.
So it may have something.
Right now,
Yeah. It may be doing something in there too. I just know that ring on the front of it is a quick focus. Real nice. Okay. Like if you take, for instance,
you need to get it real sharp. I guess you have to adjust it.
I'll show you real quick. If you look right here, if you got something real fine like that,
Yeah, it's already.
and then if you have the seat, you got that like that right there. So you can get it dead on or go too far that way, and you can find that sweet spot in there like that. If you change your distance, then you may have to do that again, like that. So this is called a document camera, and the Barney, somebody at school, I think Jennifer Wiley, I think discovered that camera back before she left. Shared that with everybody, and Barney got a bunch of them for all of us, and that was great. So Barney supports us really, really well. So Let's go here. And that's perfect. So that when you press it, we're not going to destroy the bearing. You know, you want to support the inner race. So right now, he's getting set up now with a piece of aluminum so we don't mushroom the shaft. And the aluminum is it got up here at the ramp. So to bring that on down some, and we got our hydraulic jack here. Bringing it down. And there's not a lot of stroke on that cylinder, so you may actually end up having to put something else in there. You ain't got to go far. That's exactly right. You ain't got to go far. Now, hold on a second. Let's see who that is. That may be him. Hold on. No, that's no. Hello? No, I didn't. No. Okay. Let me say bye. My mother, she thought I was calling her. She's at Southwood Retirement, and I had to pick it up. She failed the other day. So now, yeah, go ahead. Let's see. Let's get down here where I can see the gap in there. So he's pressing. Okay, go ahead. Yeah, perfect. Keep on going. Right. That's it. So that's it. Got rid of that gap in there now. So you got it flush on that flat, on that flange there, or on the step, I'll say, on that step. He's getting ready to release the hydraulic jack there, and the ram come up. So again, your rule of thumb, Brandon, and whoever's watching this, is that this shaft here, it can be marred or mushroomed if you press it directly with that ram. So you can't do that. You got to put something softer than the shaft, like aluminum, copper, brass, something like that, so that you mushroom that, not the shaft, or you're going to produce another problem there. And you're going to end up having to grind and all that, going to make a mess. So now we're going to take this and reassemble the gearbox. Put those pieces over there. We're going to move our camera. I got it. This is the Zoom mobile here. Okay. Right. We got the Zoom mobile. We're zooming with the Zoom mobile. Got my Rubbermaid plastic cart, laptop camera. Have wheels, will travel. I tell you what, back in January, I wouldn't have never guessed that I'd be rolling a Zoom mobile around like this. I tell you, man. In 1 year, I wonder, like a year from now, kind of what we may be doing. I don't know. You just never know. Just never know. Thank the Lord, He helps. He makes a way, you know.
We may have a robot over the video.
Never know. Never know. I hope we got a robot. I like robots. I can teach you. I got a certification in it. Yeah. Panic robots in Michigan.
Not the big one.
We had a real big one. The powder coat, and I maintained that, set me off on that one. I got an electrical maintenance certificate on it. And I can do programs too. Okay, so now we got Darren up here. And let's see, let's get the camera right here. You're going to reassemble the gearbox. Okay. So I think I may get on the other side. It's going to come in from the front. Go in from the front there. That'll come apart and pick up the shelf. There you go. Now you could. Now you could. Okay, so. I may just shoot that camera on in there some. This here is a right angle gearbox that's a 1-to-1 with miter gears in there. The miter gears is when you have the bevel gears that are the same number of teeth on both of the gears, and you're not changing a speed ratio, but you're only changing like that's the actual bevel gear right there, and that's a 1-to-1. That's a 1-to-1 gear ratio with the other one that's inside the gearbox. So the purpose of this gearbox is simply to change direction. A 90. Hold on. Let's see when you go together with it. Go out. Let's go in. So tap. So down in there, you see the miter gears that are down in there. Same number of teeth as the one that's going to go in. So let's just show how you go together nice and slow with it for Brandon there. Now, come on and go in nice and slow. Right. Exactly. So you don't see your shin don't get out of line.
Make sure it's sitting in there right. It ain't. There you go.
You hold. Yeah. Perfect. Y'all see that? He's turning that, and you're getting a 90 degree change in direction there. So gearboxes like this would be chosen when you design machines that you got something turning this way, but you got to transfer that motion this way, and there's not room for whatever reason on the mechanical requirements of the process, or there may be the assembly line that you're dealing with. That you got to transfer that motion directly and just keep the exact same speed ratio. So it's called a miter gearbox. Right, there's no oil in it, exactly, yeah. So your oil plugs, you have one up here, you got one, that's a drain plug, and that would be one for washing to see if you got it full enough. So you can put it in here, open that up, and then fill it on up until it gets there, and then when you do, close them on up, and then for draining, of course, you put move in, you do that bottom one there. And the data plate's going to tell you, well, you can borrow one out of the other. If there's not one here, if it's missing, just get one. There's another, we had another one like this. It's right here. Okay. And you can double check, make sure that it's still not locked up on you like the other one was. That's wonderful, like great, excellent. Yeah, excellent. So while you're bolting all that back together, I'll get the dial indicator out. Let's see if we can actually measure backlash and run out, axial and radial run out. Let's see. We actually need like a metal plate to put that on so it can be. We actually need to bolt that down and have that stationary. So maybe what do y'all think as far as where we put that at, where we can clamp it down and have this solid? We could use. We could actually just use a C-clamp and clamp that there to that bench. and then bring that metal block around and put down. We can do that. That'll work. Yep, that'll work. Okay, so let's see. You get a little C clamp. We got everything out.
Do what? Big turkey. Going 2 burpees? Where we can replace this ratchet.
Replace the socket.
The ratchet, it keeps flipping back. It's on its own.
Wow. That camera right there, Patrick, is the best thing, man.
And that one we started out with.
Man, it's just so much better. It's got that heavy base. It feels like, I don't know if it's ceramic, but it's heavy. It feels like ceramic, you know. But it's got the light, it's got the focus on there. It's everything I was wanting in the camera, basically. But it's
And it may be better to have the manual focus since it does so good, because you may be looking at one thing and it's trying to focus on something.
and it may be fuzzing in and out while you want to speak. I've seen that on YouTube before with people. It's doing it kind of have a little mind of its own thing. So what we're doing now is he's gonna clamp down, and you may want to flip that so that we want to be able to do a dial indicator on this end. That may not want to put the handle down. Yeah. Right. So we're setting up a jig here so that we can measure run out, backlash, and run out. So we want the gearbox to be stationary when we do this, and we want our dial indicator to be stationary as well. So the dial indicator's got a magnetic base, and we're going to have metal to attach it to, and we also want that to be stationary. We're going to clamp that down. So you don't have to be fancy to do something that'll work. You just have to think about it and be creative, you know. Simple as okay, you know. Exactly. And see this dial indicator right here, it's magnetic, but it moves around until you engage the magnets. And that's why is that rocking that way? That's not good. We don't want that. So is it not flat? Is there something on, or maybe is this not flat?
We've used it before.
But it actually has a hump in it. So I'd flip it to your factory edge, because that's actually a edge that's been cut. That's not a good edge. Flip it over. Now that's a better edge there. You don't want to, even a little bit of rocking is going to make you think you got more backlash or run out than you really do. You know? Right, there you go. So when you engage the magnets, that's nice and solid there, so it's not going to throw your readings off on the die. So if you can, we can start out, if you want to do the run out readings, position this where we can see it and come in from the end, and let's do an axial run out reading. And that's going to check, that's going to give you information about the bearings. Do you have too much play in the bearings, perhaps? Because you've got those tapered roller bearings that are there. If you can hand me that shaft, got actually this is not the same one that went in there. Where's the one that came out of the other one that's yeah. Right. Okay, it's still in there, yeah. But this same type of a bearing is in there. The tapered roller bearing is inside that. So if you picture it being horizontal like that, and let's say, for instance, that you have, you got a lot of wear on that bearing there, it's going to let that shaft do an axial move like that. So that's called axial run out. And that's an extreme of exaggerated like that, because maybe the bearings are got a lot of wear on them. So you want to shoot in from the end and get a flat spot on that. You may have to move some things. Exactly. And he's getting a jig set up where we can measure that axial movement there. You just have to rotate the dial this way. Yeah, exactly. Sure you can, yeah. And you have to, you got to get it where the stem can be free. You can rotate it up some if you want to, it'd be fine like that. Do that, it'll be all right. Yep. And you want to get somewhere in the middle of the stroke of that plunger, somewhere in the middle. Not at the end and not all the way in, but in the middle, so it can actually float, give you a plus or minus reading. And you don't want interference of the stem on the body of this, so it needs to be free. Yeah. Look, you might want to move that out. We actually can. I've got a piece of flat metal we can do it with. Let's do it with a piece of flat metal. You got more reach with that. Yeah.
Ain't no handle to loosen.
There's no handle to loosen that. Get your wrench. Do you think that's got the wrench that you want?
It's better than the other.
Okay, just get you a little smaller adjustable wrench then.
Right behind.
We'll reposition the camera here for. That gooseneck, man, that's the ticket. I'm telling you, it really is. Nice, man. Very nice. That whoever come up with that, man, Huey. Thank you, Huey. Thanks, Huey. It's nice, man. I'm telling you. Plug and play. I mean, it's got software, but I haven't had to do any of that. It's just as good the way it is, you know.
Don't speak English.
Right. And look at there. See what he's doing? He's getting he's getting his, the position is set so the plunger has a definite amount of stroke. He's getting in the mid stroke of the plunger. So he does it deadheaded, and then he does it run out of stroke so he can get a true reading there. And so he's picking a flat spot on the end of that shaft there. You're not in the hole, are you? You got to get out of that hole there. Huh? You're out of the hole. Yeah, he's on the flat there. So exactly. Yeah. He's on that flat there. So y'all see that. He's on the flat. That's good. Good. And I'm gonna put that back. Let's get down like this. And can you rotate maybe and get on the top end so we can see this better? No. You can't. I mean this. Yeah, rotate that.
You might just have to leave right there. Have big bed.
Let's go. But we don't want Brandon to have to stand on his head though at home. He's gonna have to stand on his head. He may have to do that anyway. Let's go. Let's move my thing here. Now, so if you will, now zero that. The dial face, yeah. The dial face moves. That dial face will move.
I put it up. Zero it. I like this. That was helpful.
Just look at the computer over here. You got the computer here, man. Okay. Back a little bit more. You're about 1,000 off. You're at 99. A little more. See. Look at that. Okay. So here, what you're technically supposed to do is push away from it and then push back, and do like that, and just see what kind of axial play do you have. And so right now, you've only got about 1/1000th of axial run out. I push, you got about 1/2,000th, and I go that way, you got about 1.5 thousandths of play right there of axial run out. Now let's go to the book and see what does the book say.
Sure, it's pretty good.
Right. So the book says,
And if it wants less than that, it wants too much.
and does it turn? No. Huh?
We couldn't find a shim to fit there, and I guess that jammed it up.
Well, that's no good. So let's make it sure. We gotta yeah.
Have fun there, right?
The shim probably gonna be down there if you want. If it's
We
getting real
put
tight,
a shim in there.
I don't need another one.
Yeah,
If you put a shim there, it's not gonna loosen.
That's not gonna help enough. Yeah.
It's not that bad.
Yeah, you're right. It's gonna have to go down in here to separate the gears some. So we got to back up. We got a gearbox locked up. Gearbox locked up. Line's down. You better hurry up. We're losing about $5,000 a minute here, guys. I got to get that truck loaded. So he's putting the shim in there to get the gears to put a little bit of the gears a little bit of play in there. So these guys are professional shimologists. So you have Darren Branch, PhD in shimology, and you got here, and you got Matthew, also doctorate in shimology.
You don't have any warrants, do you?
I try to hide them most of the time. That one good.
And Darren also has a PhD in weldology. So if you have something going on major here, he can tack weld it. He can do whatever you want to do with it. He can get her going. If you want stick, TIG, MIG, I don't care what it is, you call him. All right, there he goes right there. That's Darren Branch, weldologist, PhD. That's Alan Strickland out there. He calls it weldology. Have you heard that? You heard that?
I don't know why it's completely loose.
You got the gears lined up in there?
That's what it is.
Gears ain't lined up.
He failed his daughter's program.
I'm just multi. I'm supposed to be doing all that.
I'm supervisor. I'm just watching.
So we're shooting now to get it loosened up where she'll move again like I did a while ago. You got to get everything engaged right. Still locked up. It was nice and smooth a while ago. Yeah. Sitting on, yeah, just, yeah. Raise it up and re-engage them. That's what I call a bind. That thing was in a bind there.
Make sure to turn so you got the
Uh-oh.
So
Will it turn now?
without turning,
She won't turn.
so there's something wrong physically in here.
This was our problem in the first place.
I had Sam down, I guess.
Right, exactly. So the problem is in your horizontal shaft, not the vertical. Yeah, so that's exactly right. Yeah. That's good troubleshooting. So if you simply loosen that up just a pinch and see if that don't free it up.
Can you put the shim on the back and do it?
Yeah, you should be able to put the shaft put the shim on the back end, it'd be less work, wouldn't it?
Freed it up, somebody spin it.
So all it takes is a little bit. That one shim will do it, you know.
Put the shim on the back.
You put the shim back in here, it's gonna be less work. If we were at Goodyear, they'd be saying, Darren, we got to hurry up and get these tires going. They got truck drivers been out there 3 hours waiting. I'm telling you. How much longer?
Yeah, you better go to your office.
Where I was at, they'd be saying, how much longer? Are we going to send it? All the women out here, the inspectors at the end of the line, they say, are we going to send them to break? We're going to send them to lunch, or we're going to send them home. What are we going to do? How much longer? Is it going to be 10 minutes, 30 minutes, or is it going to be all day long? And they put them women out there. We had a bunch, inspected 25, 30 women working the shift, a bunch. And they would put them sweeping for a certain amount of time, and then when they run out of something to do, they got real nervous. What are we going to put them doing now? We're going to send them to lunch. It's 10 o'clock in the morning, or we're going to send them home. I don't know. Yeah. So how many did you add? Two. Do you think one might be enough, hadn't it? Or how thick is that one there? You put the thickest one in there? I just picked one and just try it, see. What do you think?
Yeah, I would try one.
I would try one, yeah. Just start out with the smallest amounts you got. As long as it works smooth and you got the least amount of run out, you know. we would need the specs on this, which I don't have as far as giving you the amount of run out that's allowed in the book. The general figure for axial run out. Axial run out limit of 5 thousandths. So axial 5 thousandths according to the general number in the book, and of course each type of component is going to have its own specs from the manufacturer. So you'd always go by the manufacturer specs instead of a general spec.
You said a ratchet wrench, Mr. Beverly.
Yeah, I know. I love ratchet wrenches, man. Yeah, best invention. It's like a porta-band. It's like vice grips, man. Yeah.
Okay, half inch to 9/16.
As you go with it, is it still moving? You know, keep spot checking it. Still moving. Okay.
I about got down there.
Okay. I don't know if you might take it back far or not. But that's gonna be good.
Still going? Good. That's good. That's real good. You probably want it, so you don't end up getting it lopsided there, you know. Just like doing your lug bolts on your tires or any type of gasket for that matter. Needs to be done with a torque sequence, a little bit of time. Yeah. Zoom-mobile. Rubber-made Zoom-mobile. Lightweight wheels will travel. Yes, sir. We had the last engineer we had at our plant. His famous word, and I kid you not, his famous word was, "Durwood, we've got the zoom, zoom, zoom." I'm serious, but I ain't never heard nothing about no zoom. He ain't neither, but he would want me to hurry up. He said, "We got the zoom, zoom, zoom. You know, we got to go, go, go." I text with him every now and then, and he'll if he's needing information about PLCs or drive or something like that, he may call me. Me and him, we were a right good team at the plant. He could get on the computer and design with AutoCAD machine parts. He could design a machine, design one, build one from scratch. And he'd tell me the motions he wanted it to do. He'd pick the cylinders and have the clamps and all that stuff he wanted on there. Him and another guy out in Hall would design and build machines from scratch from the ground up, man. I mean, he's that good. And he'd tell me what he wanted it to do, the motion wise. He had all the stuff on there, and I would put the PLC on, mount the valves, and program. It's a little bit in a bind on it. We'll probably have to send the top. You might want to put one more in there now, because that's not going to get it, because you got too much friction in there now. That's going to be you're going to end up with that metal.
It was loose on the bottom, so
I put extra in there.
Yeah, that's what I would do. Yeah. Well, I'll upload this for him, and he can at least see it. But I've been told that whenever things pop up like this, if somebody is absolutely cannot be here for reasons that we know about, then they say that I need to be accommodating to that, and that's what I'm doing here, you know, with the camera and the recording. Yep, sure. Yeah, and I've got it. You know, you're looking at it right here, man. I'm telling you, you can do so much with this computer and this camera, man. It's like, man, I mean, I taught a Murphy Family Venture class completely online, no in person at all. The electrical class, I did that for like 8 sessions, and 4 hours a night. It was one Monday night a week for 8 weeks, and I taught them a lot of lighting circuits and float controls, flush tank controls for hog houses and stuff, and did it completely on the camera with real stuff at the house I was doing it with in the camera, and then them doing drawings with paint. Yes, we got a lot of compliments with the online class, and they were amazed too. It was, I was pretty pleased with to be online. It was, and guys understood a lot of stuff they didn't know before about what they had in their lighting circuits in the hog house and their flush tank controls and all. They ended up understanding a lot. That's it right there.
Oh, that was quick. Y'all can work on
that was nice, very nice. So now we're going to go back in here and take a look at our axial run out. And according to the book, you can have typical around 5,000. So have you zeroed out again?
We got 6.
Well, that's okay. I mean, I'll buy that, man. So get it set on 0. You're actually behind on. Okay, that's okay. And now push one way. That's a negative, and then go up. So you've got a total of around. You're fine. I mean, the book actually calls for around 5, so you're good to go there. And I'll show you.
So you're back on the assembly line.
Yeah, right here. Let's go to the book. Whoever's watching this. Yeah. Your axial run out limit is 5 thousandths of your TIR, total indicator reading, which means from one end of the push a stroke back and forth. So you're within there. So like I said, you've got bona fide doctor in gearboxology here, okay? So and so now we're going to check radial run out. If you want to, yeah, we got about 3 minutes left here. And so the radial run out is going to check it going whenever you jerk it this way, side to side. That's also going to tell you something about the condition of the bearings and then the clearance and the between the gear teeth. So if you can get straight up a bird's eye at it, and yep. And to be dead sure about the requirements on there, we need to get a spec sheet from Morse, that company that built that. And I know there would be specs on all that with it, but our general specs out of the book, you know, should be fine. So why do we just do this? And what could be a real problem if we didn't do it and we had issues with a lot of vibration and noise. So a source of vibration can be if you got too much axial play, too much bearing wear, or not proper clearances in there because of maybe too many shims or whatever, or bearings wear. Then if you got too much slop, it's going to induce vibration that you're not going to be able to get rid of. You won't be able to get rid of it, so you might be chasing a goose you're never going to find, you know, so to speak. So that's one way. And now if you want to grab this and go up and down with it without hitting any of this, and let's see what we got. Let's go in. And if you want a 0, let's see. Well, we got a 0. Let's go in. And let me get my thing set. Let's get the focus set. Okay. Now, so he's pushing. Hold on. Let me get your hand in the picture, which I didn't have in there. Now we're going to see him push up and push down.
It was on 0. She changed her mind.
So is that light on? No, it's not on. Is it on now? It is. So watch him. He's going to push up. And that's how many thousands? That's three. About 3.5, 3. And now pull down. So you got about minus 1 thousandths there. And then up about 3 to 4. So you got a total of about what? Maybe 5. A total TIR total indicator reading of about 5,000. So let's go. Let's see what the book says on that. Thanks, sir. So let's go nice and slow through here. Prior to alignment, the radial and axial run out of the sheave. But this is on sheaves here, but we're still talking shafts. We're still talking shafts. The dial indicator excessive run out effects could induce vibration, which is what we're talking about. We're checking to see, are we going to have a vibration source here before we even start the running machine. Radial run out should be limited to 10 thousandths of your total indicator reading, which you're within that. You got about 5 thousandths on radial, and then your axial TIR total indicator will be about 5 thousandths. So you're good to go. That's fine. Very, very good. And this is on page 231 in our book for MNT 110, by the way. If anybody's wondering where this come from, it's chapter 12. And Brandon, if you hadn't done the worksheet, it's in Moodle, chapter 12, but I've also added chapter 10 in Moodle that needs to be, we'll back it up to that because it gets into bearings. So chapter 10 is what I put in there this week. If y'all take a look at it, chapter 10 is on bearings, seals, and lubrication. And all this stuff goes together because you've got bearings in there in these gearboxes, seals. One thing that we it's actually time to go, but there, yes sir. Here you got a seal. You got a seal here, oil seal, and then you have an oil seal down here. So let's mention one little thing here. I sent everybody a YouTube link that showed a guy that took a drill, or he just pierced into that oil seal right there and ran a drywall screw through that and used the screw to pull that seal out without taking the shaft out. The book actually says do more than one. It says do a couple of them. So if you look, if we flip back over to here, picture in here taking a small drill and drilling here, maybe going 180 over here, and putting 2 small holes in there and running 2 screws in there like that, and then using those to pull to jerk that seal out. So let's see here in the book where it says that. The YouTube link that I recommended, that I sent, it actually gets into that. It's called a document canon. I mean, man, it's nice for that. Okay, so this is on chapter 10 that we're backing up to now. I do have the worksheet in Moodle. So everybody make sure that you take a look at it. Somewhere in there, I read about getting, it actually said what the guy was saying. It may have been back in 12 that it mentioned that. I actually know I had moving. Here we go right here. Right here. Now, this is telling in the book what the guy on YouTube did. So I'll read this out and then we'll stop. So this is on page 241 in our book, which is in the chapter on belts and chains. It says this: for removing and installing oil seals, cover the shaft with a thin plastic sheet that wraps around the shaft tightly and secured with tape. So they're saying wrap it like with maybe something like cellophane, real thin. Carefully remove the oil seals by drilling 2 or 3 small holes in the face of the seal and insert screws. Use the screws to gently and evenly pry the seal free off of the shaft. Completely. So there you go right there. It didn't show a picture of how to do it, but the YouTube link does. Very simple. And he used 1, and it's saying here do 2 or 3. Bigger ones, of course, you would do evenly so you don't end up getting in the mind pulling it out. Completely clean the mating surface of the seal to the housing, and you're going to put your new one on. An additional light coating of sealant may be applied to the outside of the seal and the inside of the seating area, depending on the roughness of the housing. Lightly lubricate the plastic sheeting that surrounds the shaft. Gently push the seal over the plastic sheeting until it starts to seat in the housing. Use a wooden drift like a dowel rod, something wood, and a hammer to evenly seat the seal into the housing. Or if you could find maybe even something like a piece of plastic PVC pipe that's the right diameter, that's plastic and even, and you can just tap it with a hammer and it'd be nice and even, and then wipe off any excess sealant, remove the plastic sheets. That's a way of doing the oil seal without having to tear the whole gearbox down. That's a way to safely do it. So again, that's on 241. So get into the book, read it good. If you can catch some things in there that you may have never heard. So it's very valuable. It's a really good book. I like it. We're not going to cover the whole book, but we're covering the big chunks that's in our outline. We're trying to hit those, like what Ruben had laid out. So we, as of right now, we are right here. So this is what Ruben had laid out. He's one been doing it. So lubrication, bearings, and seals, those 3 that we're getting into now, that's another big chunk of the class. Couplings and clutches and brakes, we are going to cover that. Couplings is something that we'll get into probably next week. Clutches and brakes is going to be right over there on that unit, plus I have an electric clutch and brake unit, and that'll cover all of this stuff. And so we're going to get the main gist of what the outline said for the class. We're going to get that stuff in. So this book has got so much more in there that's very good stuff. So whatever you do, hang on to the book. Don't sell the book. Don't sell the book. Just got a lot in there that, lots of stuff that it's even got stuff in there on mechatronics, which is like our automation system that's back here in the back. That's something similar to mechatronics. That'll be ELC 215 in January at night at 6 o'clock. That's an advanced automation class. You learn advanced PLC troubleshooting in there with a running line, with real stuff running, with real problems that I inject in that system. So you'll use a laptop and a multimeter and read schematics and learn how to troubleshoot like you're doing in the plant. That's a real plant situation in there.
Make sure I'm registered in that. So I got to make sure I'm registered in that.
You want now?
I said I got to make sure I'm registered in that.
Yes, sir. And we can do that. We can do it today if you want to. Like we can do it now if you want to. Get you in there.
I think I'll have 2 more classes. Just that one and one more.
The book has got so much in there: hydraulic, and electrical, and everything, piping. It's got a lot of stuff in it. So don't sell the book. Okay, now, so we're gonna shut this in the session. Yeah, okay. We'll see you after a while. See you tonight. Okay. Thank you. You guys did mighty good. Okay. So, and Patrick here. We got a veteran right here, Mr. Patrick Simpson here. veteran with Bay Valley Foods, and he's been in the maintenance field 20 what or
Still 26 years.
26 years. Yeah. And he's a darn good bass guitar player too. He can thump on a bass guitar, man, like that, like nobody around here, you know. So he's good. And he's showed us about the FLIR infrared camera, and so we appreciate that a lot. And so we're going to end this session right now and let it process so it can be uploaded for Brandon, whoever may need to watch it. And thank y'all for watching. Again, this is Durwood King with Sampson Community College, class MNT 110 maintenance procedures, and it's October 22nd, 2020. And thank you for watching, and y'all have a blessed weekend. And thank you.